Alright, this video serves to review the wave properties that we've already talked about. So as we progress, I would pause as you see a new diagram and are prompted to pause and think about your answers before I tell you the answers. I want you to be able to think for yourselves. Alright, let's get started. So on this first diagram, first think about what type of wave this is, then think about what each of the letters A, B, C, D represent. So pause, press play when you're ready. All right, I hope you said that this was a transverse wave. A would be a trough, B would be the amplitude, C would be a crest, D would be a wavelength. Also, just to review, that one wave would be equal to the wave from here to here. This is one full wave. All right. First, think about what type of wave this is. Then think about what A, B, C, and D represent. Pause. All right, so I hope that you said it was a longitudinal wave or a compressional wave. A and B are both areas of compression where these waves are closer together. They are compressed. That means that C and D are areas of rarefaction. Rarefaction. And no, it is not the same as refraction. That is waves bending. So rarefaction is the relaxed or at rest particles of a wave as they are spread out. All right, so we've already said that these are transverse waves. There are several different colors corresponding with Roy G. Biv, the rainbow. So you have 1, 2, 3, 4, 5, 6, 7 waves. Which wave has the lowest frequency, highest frequency, longest wavelength, shortest wavelength? Pause it and maybe write down your answers just so you don't forget them. Okay, so for the lowest frequency means the fewest amount of waves. So that's going to be red. So red has the low frequency. All right, what about the highest frequency? Well, the complete opposite. So you'd want to have the most amount of waves. So violet would be the most or highest frequency, the most amount of waves. All right, what about the longest wavelength? Remember, wavelength is the measure from crest to crest. So if you did a measure from each crest to crest, you notice that as we go through the colors, they're getting closer and closer together, right? So the longest wavelength is still going to be red. That is the longest wavelength. So the shortest wavelength is going to be the purple. Notice how the shortest wavelength goes with the highest frequency. The longest wavelength goes with the lowest frequency. All right. Last review. So as the frequency increases, the wavelength blank, because they are blank related. So think about two words that could go in those blanks and pause until you're ready to hear the answer. All right, so as frequency increases, the wavelength decreases because, if we just have an average wave compared to a high frequency wave, you'll notice that the wavelength decreases. Here it's really long, here it's super short. And that is because they are inversely or oppositely related. So as one increases, the other one decreases. All right, thanks for watching the review. Stay tuned for more.